Hello, my fellow animal lovers. How are you today? Before I ferry you to dreamland, if you love the content and you love animals, I encourage you to show your support by subscribing. By the way, tell us where you are in the world in the comments section. What time do you like watching our channel? I look forward to reading all your comments. Enjoy. Chapter 1: The Gate of Soft Earth. Deep in the longleaf pine forests, where the sun reaches down through a sparse canopy to warm the earth, lives a creature of immense, unhurried time. This is the gopher tortoise, a land-dwelling soul with a life that unfolds across 4 to 6 decades in the quiet wilds. Though some individuals in protected environments have been documented to live for over 90 years. The gopher tortoise holds a unique position as one of only 5 extant tortoise species native to North America, and it stands alone as the only tortoise species found naturally east of the Mississippi River, with its historical range extending from southern South Carolina across Florida and westward into portions of Louisiana, Mississippi, and Alabama. Its movements are characterized by a calm, deliberate patience. Its ancient shell, a domed brown-gray shield that appears to hold the memory of generations, bearing the subtle marks of its slow passage through time. This species is intrinsically linked to the longleaf pine ecosystem, which historically spanned approximately 90 million acres from Virginia to Texas. Today, tragically, less than 5% of this magnificent original range remains, primarily due to human activities like development and agricultural conversion. This ecosystem is not merely a static backdrop, but a vital, dynamic, and fire-adapted habitat. It is characterized by an open, often airy canopy of mature longleaf pines, a conspicuous absence of dense mid-story trees and shrubs, and a remarkably rich, diverse ground layer dominated by a plethora of native grasses and flowering herbaceous plants. The frequent, low-intensity natural fires, often ignited by lightning strikes, are not destructive, but rather essential for maintaining this open, park-like setting. These fires clear accumulated leaf litter and promote the vigorous growth of the ground cover plants that constitute the gopher tortoise's primary diet. The tortoise is an ectotherm, a biological term indicating that it relies on external sources of heat to regulate its body temperature. Unlike mammals or birds, its internal temperature fluctuates with the surrounding environmental conditions, necessitating strategic management of its exposure to sun and shade. As the afternoon light grows too bright and the sun's warmth becomes a heavy, almost oppressive blanket, a new rhythm begins for the tortoise. It instinctively seeks the cool, inviting touch of the earth, particularly in well-drained sandy soils, which offer the ideal substrate for burrow construction. Its forelimbs are extraordinarily adapted for excavation, resembling small, sturdy shovels. These limbs feature flattened, scoop-like structures armed with strong, blunt claws that are perfectly designed for digging. Its hind feet, in contrast, are described as being round and pad-like, almost elephantine, in their slow, heavy, yet remarkably efficient placement, providing crucial stability and powerful propulsion during the digging process. It begins the slow, rhythmic work of digging, a patient, profound labor that can last for hours. One powerful claw moves, precisely pushing cool, fine sand backward and out of the way. Then another claw moves, another soft, deliberate push. This simple, repetitive motion of a creature moving earth against its body becomes a calm, unhurried, almost meditative rocking, a testament to its innate connection with the ground beneath it. The entrance to the tortoise's home, a testament to its tireless effort, is a quiet gate shaped distinctively like a half moon. Just beyond the opening, a substantial mound of loose, excavated soil spreads out like an apron, a hallmark feature that immediately distinguishes an active gopher tortoise burrow from other animal dens. This apron is composed entirely of the sand that the tortoise meticulously scraped and pushed out during the construction of its subterranean dwelling. The size of the burrow entrance is typically proportional to the tortoise occupying it, generally mirroring the width of the tortoise's own shell length, which allows the animal sufficient space to turn around comfortably inside. The creation of this intricate burrow is a long and unhurried process, a low stakes endeavor that can span weeks or even several months to complete, depending on factors such as the specific soil type, the tortoise's size, age, and environmental conditions. There is no discernible rush, there is no urgency. The gopher tortoise is simply doing what it must, fulfilling an ancient biological imperative through a quiet, repetitive task that mirrors the natural, unhurried unfolding of time itself. This soft, patient labor acts as a kind of silent sanctuary for the mind, occupying it with the simple, rhythmic motion of a creature settling in for a long, peaceful rest. The burrow is more than just a physical refuge. It is a profound escape from the intense surface heat, the biting cold, and the distant, often unsettling hum of the world above. It is an act of being physically and mentally cradled by the earth itself. Gopher tortoises are known to utilize multiple burrows within their individual home ranges, with the number varying based on geographical location, seasonal needs, and individual tortoise preferences. This intricate network of burrows further underscores their vital role as essential ecosystem engineers, shaping the landscape far beyond their own needs. Chapter 2: The Chamber of Stillness. The journey into the burrow is a profound journey into stillness, a gradual descent from the dynamic surface world into a realm of consistent calm. The tortoise begins its gentle, slow descent, moving along a meticulously excavated tunnel that angles downward at a low, unthreatening slope, creating a slow, meandering passage into the perpetual dark. While a typical gopher tortoise burrow averages about 15 feet in length and reaches depths of around 6.5 feet, some exceptionally long burrows have been known to stretch to 40 to 50 feet in length, and depths can sometimes exceed 10 feet, depending on the local soil depth and the underlying water table. These burrows are often strategically located at the base of natural features such as fallen logs, large rocks, or established plant roots, which provide additional structural support and natural camouflage, enhancing the burrow's stability and concealment. With each slow, deliberate movement forward, the bright, scattered light of the day gradually fades, eventually giving way to complete darkness. Concurrently, the world of sound becomes hushed, muffled, and absorbed by the dense weight of the surrounding earth, creating an unparalleled acoustic quietude. This journey is a passage from the changeable, often volatile world of the sun and the wind into a place of profound and constant calm. The burrow is a remarkably stable space that maintains a steady temperature and a gentle, consistent humidity year-round. This makes it a critical thermoneutral space for the gopher tortoise, a true haven. As an ectotherm, The tortoise's survival is fundamentally dependent on these stable conditions to regulate its body temperature, allowing it to avoid the potentially lethal extremes of surface heat during the scorching summer months and the biting cold of winter frosts. For instance, while surface temperatures in the longleaf pine ecosystem can fluctuate wildly by dozens of degrees within a single day, Burrow microclimates exhibit significantly less hour to hour variability and are far less prone to extreme temperature swings, providing crucial respite. Scientific research has consistently shown that even the burrow entrances can provide substantially cooler microclimates, sometimes by an average of up to 11.3 doxal compared to the exposed apron during the peak of summer, making them vital basking or cooling spots depending on the time of day. The consistent moderate temperatures within the main chamber of the burrow and the relatively high humidity are absolutely essential for the tortoise's delicate physiological processes, including metabolism and hydration, and for its overall long term health, effectively preventing desiccation and severe thermal stress. Here, within these earthen walls, time and temperature seem suspended, operating on a different, more ancient rhythm. This stability is a quiet wonder, a profound gift from the earth itself. The feeling of the earth here is akin to the softest, most comforting presence imaginable. The fine, cool sand, meticulously smoothed by the tortoise's own movements, feels soothing against its domed shell. The complete absence of wind, or even a gentle breeze, creates a deep, abiding quietness, a unique humming silence that perceptibly fills the entire space. It is in this place that the earth seems to possess a silent music all its own, a subtle resonance audible only to those who are still enough to truly hear it. The earth itself seems to breathe in a slow, steady rhythm, and the cool sand cradles the tortoise, holding it safe and secure in its profound embrace. This physical state of a stable microclimate transcends mere survival. It becomes a soothing metaphor for inner peace, guiding the listener's own body and mind toward a similar state of gentle, unchanging calm and deep rest. The burrow is more than just a shelter. It is a nurturing, active force, a deep embrace that feels like a refuge for a mind seeking an ultimate sense of safety and stillness. It is a vital sanctuary, not only from temperature extremes, drought, and predators, but also from natural disturbances like wildfires. These fires are a regular and necessary part of the longleaf pine ecosystem, essential for its health and renewal. When fires sweep through the landscape, the gopher tortoise and countless other species retreat to the insulated depths of the burrow, waiting out the flames in perfect safety, emerging later into a revitalized landscape. Chapter 3: The Gathering of Many. In the deep quiet of the gopher tortoise burrow, there is a profound sense of not being alone. Indeed, it is a bustling, hidden world beneath the earth teeming with life. This is not a place of solitary retreat, but rather a quiet subterranean village hidden within the earth's embrace. The gopher tortoise, in its slow and patient work of excavation, has become an unintentional yet benevolent and silent creator, providing a vital home and essential refuge for an entire community of creatures. The burrow is unequivocally recognized as a keystone species habitat, sheltering an astounding number of other species. Scientific studies and observations have cataloged anywhere from at least 350 to over 360 different species that depend on these burrows for their survival. This makes the gopher tortoise a true ecosystem engineer, meaning its physical presence and ongoing activities have a disproportionately large and fundamental impact on its environment relative to its own abundance. By digging and maintaining its burrow, the tortoise fundamentally shapes the biodiversity, ecological health, and overall structure of its longleaf pine habitat. These burrow inhabitants represent a diverse cross section of regional fauna, including a wide range of mammals, amphibians, various reptiles, birds, and an incredibly vast array of tiny insects and other invertebrates. These inhabitants are the quiet neighbors in this shared space, many of whom are known as commensal species. This term refers to animals that obtain crucial food, secure refuge, or other vital benefits from the burrows without causing any harm to the tortoise itself. Some commensals are even largely or entirely dependent on these burrows for their very existence, unable to survive without access to the stable microclimate and protection they offer. For instance, the gopher frog, a medium-sized amphibian naturally found in the open land and fire-maintained habitats of the longleaf pine ecosystem, finds its indispensable home here. It relies on the burrow not only for shelter from predators and temperature extremes, but also as crucial breeding sites, as the burrows often extend below the water table, providing temporary ponds for tadpole development. Its presence is typically a quiet one, but its distinctive breeding call, used during mating season, can be described as a gentle, low sound, almost like a deep snoring that reverberates subtly through the dark, humid chambers of the earth, a unique lullaby of the underground. Further inside, the Florida mouse, a small rodent characterized by its proportionally large ears and eyes, is a prime example of an obligate commensal. It literally cannot exist in its natural range without the presence of the tortoise burrow, digging its own small U-shaped side tunnels off the main passage, acting as a quiet, industrious neighbor with a gentle yet critical purpose. Other significant reptilian guests include the federally threatened eastern indigo snake, a large, non-venomous, and generally docile snake that frequently utilizes these burrows, particularly during the colder months for vital refuge. Critically, even species like the eastern diamondback rattlesnake, North America's largest venomous snake, commonly seeks seasonal refuge in gopher tortoise burrows, highlighting the universal appeal and necessity of these underground sanctuaries across the food chain. This peaceful gathering of creatures within the tortoise's self-made home powerfully demonstrates that the refuge of the burrow is a truly magnanimous gift for all who seek its shelter. Each of these diverse animals uses the burrow for essential protection from the myriad dangers of the world above, acting as a literal haven from the extremes of heat, the biting cold, the ever-present threat of fire, and the constant danger of predation. The consistent, stable microhabitat within the burrow provides environmental conditions that are otherwise unavailable and unsustainable on the surface. Beyond simply providing direct shelter, the tortoise's continuous burrowing activities profoundly influence soil structure, aerating the earth, improving drainage, and enhancing soil nutrient cycling through the redistribution of organic matter from deeper soil layers to the surface. Furthermore, the excavated sand of the apron creates unique soil conditions that promote the establishment and diversity of specific plant species, often different from the surrounding undisturbed areas, further enriching the entire ecosystem around the burrow entrance. The quiet, tireless work of the gopher tortoise, the seemingly simple act of building a home for itself, thereby creates a profound chain of quiet benefit, a powerful and calming thought that a single unassuming act of peace and industry can ripple outward to create a world of safety and sustenance for many. The gentle shared existence of these creatures within the burrow's protective walls unequivocally shows that there is enough quiet, enough darkness, and enough stillness for all who need it, underscoring the vital conservation implications of protecting this truly remarkable keystone species. Chapter 4: The Pause of Torpor. To truly understand the profound surrender of the burrow's deep rest, one can draw a striking parallel from a creature of the air, a being that embodies almost impossible energy, the hummingbird. This tiny avian marvel lives a life of ceaseless explosive energy, maintaining one of the highest metabolic rates among vertebrates. Its wings move in an astonishing blur, beating at speeds of 50 to 80 times each second in normal flight, sometimes reaching over 200 beats per second during aggressive dives or courtship displays, creating the distinctive soft hum from which it takes its name. To sustain this furious pace, hummingbirds must constantly feed on nectar and small insects throughout virtually every waking moment of the day, consuming their body weight or more in food daily. Its tiny heart races at speeds of up to 1,200 beats per minute, a furious, brilliant drumbeat necessary to power its ceaseless flight and maintain its consistently high body temperature, typically around 105 Fef. This hyper-fast metabolism means they are always on the brink of starvation, especially during periods when food is scarce or temperatures drop. But as the day ends and the light softens and gracefully fades away into twilight, this creature of furious energy must find a way to dramatically slow down and conserve its precious resources. The hummingbird, which is also an ectotherm in its fundamental need for external warmth, possesses a specialized and truly fascinating ability to surrender completely to the night's embrace. It finds a familiar perch, often a protected branch or a sheltered spot that offers some degree of cover where it can conserve its critical energy reserves, usually in a safe, secluded location that offers minimal exposure to wind and cold. There, as the vibrant world of daylight closes its eyes, its tiny body undergoes a profound physiological change, entering a deep sleep-like state known as torpor. This isn't merely regular sleep, it's a controlled physiological shutdown, a state of reduced metabolic activity that allows the bird to survive extended periods of food scarcity or dangerously cold temperatures when its high metabolic rate would otherwise quickly deplete its energy stores, leading to starvation. In this remarkable state, the small bird's core body temperature drops dramatically, sometimes by almost 50 degrees Fahrenheit from its active temperature, settling to match the cool air around it, sometimes falling as low as 60 to 70. This is a significant decrease from its active body temperature of around 105 Beth. Its breathing slows to barely perceptible, shallow breaths from hundreds per minute to a mere whisper, and its heart rate, once a frantic drumbeat of over 1,000 beats per minute, can plummet to fewer than 50 beats a minute, sometimes even as low as 30 beats per minute in some species. A hummingbird in torpor may appear stiff, unresponsive, and even lifeless, hanging upside down or appearing inert on its perch, its feathers ruffled, but it is perfectly safe cradled by the quiet of the night. This state is not a forced involuntary act, but rather a deliberate, evolutionarily fascinating, and crucial way to conserve energy, reducing its metabolic rate by as much as 95% compared to its active daytime state. This is a natural, elegant solution to the existential problem of a long, cold night without sufficient food, a problem that would otherwise be fatal for such a small, energy demanding creature. When the life giving sun finally returns, typically with the first light of dawn, the hummingbird will gently shiver its way back to full life. This shivering, a rapid contraction of its muscles, generates internal heat that gradually warms its body back up to its normal, active temperature within about 10 to 20 minutes, a small burst of energy to prepare for the day. The hummingbird's extraordinary ability to surrender so completely to rest is a graceful, profound lesson in the art of letting go, illustrating nature's intricate and awe-inspiring strategies for survival and optimal energy management. Much like the gopher tortoise's reliance on its burrow for thermal stability, the hummingbird's torpor is a testament to the diverse ways creatures adapt to their environment to find periods of critical stillness and energy conservation. Chapter 5: The Weaver's Cocoon. The deep earth holds other, equally fascinating secrets of quiet transformation, secrets of meticulous natural engineering, solitary perseverance, and profound patient metamorphosis that unfold in hidden realms. Consider the mason bee, particularly species like the common blue orchard mason bee, a creature that lives a distinctly solitary life, a stark and intriguing contrast to the complex communal and hierarchical existence of social insects like honeybees or bumblebees. There is no intricate hive structure, no dedicated worker bees, and no queen to serve in a collective hierarchy. Instead, each individual female mason bee is an independent architect and, in essence, a queen unto herself, singularly responsible for all aspects of nest building, provisioning her offspring with food, and ensuring the survival of her own progeny, a remarkable feat of self reliance and instinctual dedication. Her work is a singular, unhurried, and highly purposeful endeavor, driven by a deep biological imperative. Her body is uniquely adapted for pollen collection, not on her legs, but covered in stiff, branched hairs on the underside of her abdomen, collectively known as a scopa. She uses these specialized hairs to meticulously collect and transport pollen, performing a gentle, fuzzy process that makes her an exceptionally magnificent and efficient pollinator, often proving more effective per individual bee than honeybees for certain specific crops, like fruit trees, due to her less precise pollen packing and thus greater pollen dispersal. Unlike the honeybee, which compacts and carries pollen in specialized baskets on its hind legs, the mason bee carries pollen loosely on her belly, a soft pollen-dusted passenger. This method is incredibly effective because as she moves actively between flowers, she continuously brushes pollen off her abdomen onto the floral reproductive parts, facilitating more thorough cross-pollination with every single visit, making her an invaluable agricultural ally. To build her intricate home, she meticulously seeks out a narrow, pre-existing tubular cavity or a hollow stem. These can include abandoned beetle tunnels in dead wood, the hollowed-out pith of various plant stalks, naturally occurring cracks in rocks, or even artificial bee houses and nesting tubes, specifically provided by human conservationists who understand her value. This small, dark, cylindrical space is where she can begin her methodical, repetitive, and deeply instinctual work, an art passed down through countless generations. Importantly, she does not excavate these tunnels herself, but relies entirely on finding suitable existing structures, a clever adaptation that conserves significant energy and time. Once a suitable cavity is located and thoroughly inspected for size and safety, she begins the intricate process of constructing a series of individual cells for her offspring within it, a linear progression of nurseries. She makes numerous, often 10 or more, diligent and precise trips to a nearby source of moist clay rich mud, frequently preferring specific soil types that offer the ideal consistency for her building material, often mixing it with her own saliva to achieve the perfect pliability and adhesiveness. Each trip is a small, patient journey, returning with a tiny, carefully molded pellet of mud, no bigger than a grain of sand. She brings this mud back and meticulously uses it to construct a series of internal walls, creating perfect sealed dividers between the individual chambers of her linear nest. This mud possesses a unique consistency, with a rich clay texture that can be kneaded like modeling clay, a soft, pliable substance that she skillfully manipulates with her mandibles and forelegs to seal her work with remarkable precision and care, providing both structural integrity to the nest and crucial protection against predators, parasites, and environmental fluctuations. Inside this protected linear space, within each meticulously sealed cell, her offspring undergoes a silent yet profound transformation, a hidden miracle of nature. First, the female bee lays a single egg at the very back of the newly constructed cell, then provisions it generously with a carefully prepared pollen loaf, a meticulously mixed blend of pollen and nectar she collected, precisely measured to sustain the developing larva. This serves as the sole food source for the developing larva, providing all the necessary nutrients and moisture for its arduous journey of growth. It is a process that happens entirely in the quiet, undisturbed, and utterly dark solitude of the sealed chamber. The larva slowly and steadily eats its loaf of pollen, gradually consuming the stored food to fuel its growth throughout its journey. Once it has consumed enough and reached its full larval size, it then spins its own intricate silken cocoon, a delicate yet remarkably durable, silky tomb that provides an additional layer of protection for its long slumber and metamorphosis. This cocoon, often reinforced with bits of chewed plant material or soil particles, provides crucial insulation against temperature swings and defense against desiccation and external threats, including fungal infections. Within this cocoon, as the autumn transitions into winter and then the promise of spring, the unseen work of complete metamorphosis unfolds. Slowly, in the dark and cold, the larva transforms first into a pupa, undergoing a remarkable reorganization of its body plan, shedding its larval skin multiple times, and then finally into a fully formed adult bee, complete with intricate wings, segmented legs, and sensitive antennae, a perfect miniature of its parent. It is a profound biological process that beautifully mirrors a caterpillar turning into a magnificent butterfly, a deep transformative change that happens in perfect quiet stillness, entirely hidden from the outside world. The mason bee's hidden work, the solitary meticulous construction of its nest, and the silent profound transformation within is a gentle reminder that some of the most beautiful and complete changes happen in the dark, in moments of deepest, most profound rest and protected seclusion, culminating in the emergence of new winged life ready to contribute to the ecosystem's vibrant pollination cycles, a testament to the power of hidden processes. Chapter 6: A Silent, Slow Passage. In the deep, shared sanctuary of the Gopher Tortoise burrow, an unexpected but welcome guest arrives, moving with a silent, almost ethereal grace that brings a final, encompassing layer of peace to the subterranean community. This is the magnificent eastern indigo snake, a truly impressive and imposing reptile that can often reach remarkable lengths of 6 to 8 feet, making it the longest native snake species in North America, with some exceptional individuals documented to exceed 9 feet in length. Despite its substantial size and powerful muscular build, it moves with an unhurried elegance, a long, quiet, iridescent blue-black shadow gliding almost imperceptibly over the cool, packed earth of the burrow floor. Its common name, indigo, perfectly describes its stunning, glossy, purplish-black scales, which can shimmer with a mesmerizing iridescence in certain light, giving it a unique, almost regal appearance. It is a non-venomous and generally peaceful member of the burrow community, often known for its remarkably docile temperament and reluctance to bite when unthreatened, making it a charismatic species. Its purpose on this journey into the earth is not to hunt within these confined spaces, as its varied diet primarily consists of other snakes, small mammals, birds, and amphibians encountered above ground. Instead, it seeks essential refuge and restorative rest, particularly during periods of environmental stress or for crucial seasonal cycles. This ancient reptile is classified as a priority commensal, signifying its critical dependence on the gopher tortoise's burrows for its very survival, especially in regions where suitable natural refuge are scarce. It is one of the many creatures that rely heavily on these subterranean havens, particularly during the colder months of winter, for overwintering or during periods of extreme summer heat when surface temperatures become dangerously high, posing a risk of heat stroke or desiccation. It seeks a place of quiet, stable refuge, a safe haven from the biting wind, freezing temperatures, and the ever-present threat of wildfires that periodically sweep through its natural longleaf pine habitat, posing a significant danger to surface-dwelling creatures. The journey of the eastern indigo snake into the burrow is a slow flowing river of a movement, a seamless undulation of its powerful muscular body. Its smooth, highly polished, friction reducing scales glide effortlessly and silently over the cool, packed sand of the burrow's floor, creating barely a whisper as it proceeds, a testament to its efficient locomotion. There is no urgency in its motion, only a profound, rhythmic grace as it follows the gentle, meandering curve of the tunnel, a living embodiment of the calm and stability the burrow provides. It is instinctively drawn to the same place of stillness and consistent temperature as the tortoise, seeking the stable, unchanging microclimate that offers unparalleled protection from all that is harsh and fluctuating outside. As an ectotherm like the tortoise itself, the indigo snake depends entirely on external environmental conditions for its body temperature regulation. During colder periods, the burrow provides a crucial thermal refuge that is significantly warmer than the freezing surface, preventing dangerous metabolic slowdowns or the potentially lethal effects of freezing. Conversely, during hotter periods, It offers a crucial escape from scorching surface temperatures, preventing overheating and desiccation, which could be fatal. The burrow's consistent temperature and humidity levels are absolutely crucial for its physiological well being, enabling it to conserve energy, avoid thermal stress, and sustain its vital bodily functions during periods of environmental extremes, a perfect natural incubator. The pervasive presence of this silent, majestic traveler further reinforces the deep, unshakable safety and profound ecological importance of the gopher tortoise burrow. A single subterranean space that can consistently shelter the industrious Florida mouse, which meticulously digs its own small side tunnels for its young, provide refuge for the peaceful, distinctive snoring of the gopher frog, whose life cycle is intricately tied to the burrow's ephemeral ponds that may form at its deepest points and accommodate the long flowing body of the impressive eastern indigo snake, is truly a space of abundant quietude, shared resources, and unshakable security for a diverse assemblage of life. The eastern indigo snake, being federally threatened in much of its range due to habitat loss and other pressures, finds critical refuge in these burrows, underscoring the gopher tortoise's irreplaceable role as a keystone species and ecosystem engineer, a living testament to interspecies reliance. There is enough of this profound peace, enough of this protective darkness, and enough stable environment for all who need it, demonstrating nature's capacity for shared survival. The snake's calm, silent arrival adds a final, rich layer to the sense of a world that is not only safe, but also deeply tranquil and rich in its stillness and interconnectedness. Its calm, slow passage is a final, calming image, a symbol of silent, flowing grace, joining the quiet, diverse community harbored within the earth, a poignant testament to the intricate web of life sustained by the modest yet monumental efforts of the gopher tortoise. This profound interspecies reliance highlights why the protection of the gopher tortoise is not merely about preserving one species, but paramount to the conservation of broader biodiversity and the entire longleaf pine ecosystem across the southeastern United States. Chapter 7: The Final Deep Rest. The long and patient journey inward is now complete. We return to the gopher tortoise itself, having followed its profound descent, now settled comfortably and securely at the deepest, most stable point of its long, meticulously crafted burrow. Here, in the final, innermost chamber, often a slightly expanded terminal chamber, the stillness is absolute, a profound quietude that permeates every grain of sand, creating a palpable sense of peace that wraps around the creature. This is the ultimate place of true and lasting refuge, a sanctuary perfected over millennia of evolutionary adaptation and instinctual design, often referred to as the tortoise's primary retreat or hibernaculum during winter months, or a estivatorium during extreme summer heat. Overhead, the immense comforting weight of the earth itself, often several feet thick, forms a heavy protective blanket, providing a final unshakable layer of security and insulation against the fleeting and often perilous dangers of the world above. This deep chamber is precisely where the tortoise comes to be safe from the intense scorching summer heat that can reach lethal temperatures on the exposed surface, often exceeding 100 F 38 Gers and causing heat stroke from the destructive, fast moving force of wildfires that regularly sweep through its longleaf pine habitat, consuming all in their path and generating intense heat from the biting, often freezing cold of winter frosts and severe temperature drops, which can plunge below freezing for extended periods, posing a hypothermia risk, and from the constant, omnipresent threat of predators, both terrestrial, like coyotes, bobcats, raccoons, and even domestic dogs, and avian, like raptors for juveniles, or larger predators for adults that venture too far from the burrow. The air within this innermost chamber is consistently cool and refreshingly humid, providing a physiologically ideal microclimate that minimizes crucial water loss through evaporation and prevents severe thermal stress for the tortoise. While surface humidity can fluctuate dramatically throughout the day and seasons, the burrow maintains a remarkably stable, high humidity, often around 80%, which is absolutely crucial for ectotherms that are susceptible to desiccation. The fine, densely packed earth of the burrow, meticulously smoothed and shaped by generations of tortoise movements, feels soft and yielding, yet supportive against the tortoise's domed shell, providing a profound tactile sense of groundedness and ultimate safety, a natural cradle. This sacred place is filled with a velvety, impenetrable darkness, a deep, peaceful absence of light that effortlessly invites the eyes to close and the mind to fully disengage from the anxieties, visual stimuli, and constant vigilance required in the external world. Listen now with an attuned inner ear for the quiet, subtle sounds of the burrow's many inhabitants, a gentle, almost imperceptible rhythm of breathing in the profound silence, the faint, soft rustle of an unseen insect moving through the sand of a side tunnel, or the distant, lazy snoring sound of the gopher frog, its unique breeding call sometimes resonating from the deeper, often water filled sections of the burrow, especially after heavy rains, signaling life even in the depths. This lulling, reassuring lullaby of the underground is a final comforting signal that all is unequivocally well and secure in this shared, deep, and communal sleep, a harmony of unseen life. The gopher tortoise and its diverse array of quiet neighbors are held securely in this profound stillness, each benefiting equally and symbiotically from the stable, unchanging microclimate created and painstakingly maintained by the tortoise's patient, tireless labor. The entire journey from the bright, active, and often challenging world of the surface to the deep, silent peace of the earth's heart has been one of slow, deliberate, and gentle surrender, a descent into sanctuary. The tortoise may enter a state of reduced activity or brumation during extreme conditions, conserving precious energy efficiently and minimizing its physiological demands. There is nothing left to do now but to simply be, to exist purely in the present moment, free from the demands of external vigilance or physiological struggle, a state of ultimate tranquility. To feel the cool, fine sand that cradles its ancient shell, a natural bed formed by its own efforts, to rest deeply in the unchanging, comforting dark, surrounded by the quiet hum of earth and fellow inhabitants. This is the profound peace that comes from being fully immersed in a world of gentle, slow, and ancient processes, a fundamental rhythm of nature that predates human hurriedness and modern anxieties. This deep rest is not merely a passive state of dormancy, but an active, regenerative process, allowing the tortoise to recuperate, repair tissues, and prepare its body and metabolism for its next period of activity above ground. when it will emerge renewed. The journey inward is complete, and the final stillness achieved is absolute, serving as a powerful and enduring testament to the unparalleled refuge and stability offered by this remarkable creature's unassuming yet monumental underground home, a testament to nature's inherent wisdom in balancing energy expenditure with critical periods of profound tranquility and resilience. Chapter 8: The Return of Light. As the seasons meticulously turn and the earth completes its slow, inevitable revolution around the sun, bringing forth the promise of renewal, a subtle yet profound shift begins within the silent earth, signaling a new rhythm and the impending return to the vibrant, active world above. For the gopher tortoise, this awakening from its deepest period of rest, whether brumation in winter or aestivation in extreme summer heat, is a gradual process, closely tied to the specific environmental cues of steadily warming air and soil temperatures and increasing daylight hours. While often considered active year-round in the warmest, most southerly parts of their range, such as central and southern Florida, where temperatures rarely drop below freezing for extended periods, their peak activity outside their burrows typically occurs during the warmer months, roughly from May through August, when food is abundant and conditions are optimal. In the cooler, more northerly parts of their range, e.g., South Carolina, Alabama, Georgia, tortoises may remain ensconced within their burrows for longer durations during colder winter months, sometimes for weeks or even months of relative inactivity, minimizing energy expenditure. However, they are not true hibernators and will often emerge on exceptionally warmer, sunny days to bask near the burrow entrance or forage briefly for a few hours before prudently retreating back to the burrow's consistent warmth as temperatures drop. Studies using telemetry and temperature loggers have shown that while daily activity peaks in the mornings and late afternoons, tortoises frequently return to their burrows well before the hottest part of the afternoon, demonstrating their continuous reliance on the burrow for thermoregulation. This period of increased activity also marks the crucial time for reproduction, a vital phase that ensures the next generation can begin its life during the most favorable conditions for growth and survival. Gopher tortoises generally engage in breeding activities from March through October, though male courtship behaviors, including head bobbing displays and shell ramming competitions for access to females, can extend into late summer or fall. The most intensive nesting season primarily occurs from late April to mid-July after successful mating. Female tortoises, which are typically slightly larger than adult males, males often have a concave plastron or lower shell, and longer gular projections used in courtship, will lay a single clutch of eggs per year, though in some instances, a second, smaller clutch may be laid if environmental conditions are exceptionally favorable and energy reserves allow. The number of eggs in a clutch typically ranges from a modest 3 to 15, with an average of 5 to 9 eggs, often described by their size and shape as ping-pong ball-sized, approximately 1.5 inches or 3.8 centimeters in diameter. These eggs are almost exclusively deposited in open, sunny locations that allow for optimal solar incubation, as ambient temperature directly influences hatchling development. Most commonly, a female will meticulously excavate a small, shallow, bottlenecked nest cavity within the soft, loose sand of the mound, the apron, at the very entrance of her own burrow, maximizing convenience, camouflage, and proximity to immediate shelter. This strategic placement ensures the eggs receive ample sunlight for incubation, as the sex of the hatchlings is often determined by the temperature of the nest, a fascinating phenomenon known as temperature dependent sex determination, TSD, which is common in many reptile species. Warmer nest temperatures, typically above 30 torr, 86 Feb, tend to produce more females, while cooler temperatures below 30 torr yield more males, a natural balance mechanism. The incubation period for gopher tortoise eggs can vary significantly based on geographical location, average ambient temperatures, and specific nest site conditions, typically ranging from 80 to 110 days, with longer periods in cooler northern ranges. Hatchlings, with their bright yellow-orange carapaces that gradually darken with age to the adult brown-gray as they mature, typically emerge from their nests between late August and early November, coinciding with the end of the summer rains and the onset of more moderate autumn temperatures. Their emergence marks an incredibly precarious and vulnerable stage in their lives. These tiny tortoises, initially only a few inches long and with soft, pliable shells, are immediately faced with the immense challenges of survival, as they are born with a fully functional instinct for independence and receive no parental care whatsoever. Young gopher tortoises, due to their small size and relatively soft shells, face immediate and highly significant threats from a multitude of opportunistic predators, including raccoons, foxes, skunks, armadillos, opossums, various birds of prey like hawks and owls, and even other snakes that specialize in eating young reptiles. Their shells do not fully harden and ossify until they reach approximately 6 to 7 years of age, leaving them highly vulnerable during their formative years. Sadly, extensive research indicates that only about 25% of all eggs laid in the wild successfully hatch, and a mere 10% of those hatchlings survive their perilous first year, a stark reminder of the harsh realities of natural selection. Furthermore, gopher tortoises exhibit no maternal care whatsoever of their eggs or young after oviposition. Hatchlings are entirely self-sufficient from the moment they emerge, instinctively either digging small, rudimentary burrows of their own or utilizing existing adult burrows for immediate shelter and protection. This slow reproductive rate and critically high juvenile mortality rate underscore the species' inherent vulnerability and the immense importance of every surviving individual to the long-term health and genetic diversity of the population. As the adult tortoises and new hatchlings emerge from their underground retreats, they resume their essential foraging activities, primarily consuming a diverse diet of low-growing plants, various grasses like wiregrass and broadleaf grasses, legumes, and succulent fruits like gopher apple, pawpaw, and blackberries, which are critical for their growth and energy. In doing so, they inadvertently act as crucial seed dispersers, contributing significantly to the plant diversity and ecological resilience of their longleaf pine habitat, completing a vital ecological cycle. This cyclical emergence and return to the surface world highlight the intricate symbiotic dance between life above and below ground, all facilitated and sustained by the enduring presence of the indispensable gopher tortoise burrow, a testament to life's persistent rhythms. Chapter 9: The Enduring Legacy. The profound story of the gopher tortoise is far from over Indeed, it is an ongoing vital narrative of remarkable resilience, unparalleled ecological significance, and the urgent imperative for robust and comprehensive conservation efforts in the face of escalating anthropogenic pressures. This ancient species, whose evolutionary lineage can be traced back nearly 60 million years, predating many modern mammals and even some dinosaurs, holds an irreplaceable and pivotal place in the rich biodiversity of the southeastern United States. However, despite its deep historical roots, its incredible longevity, and its immense ecological importance, its populations have experienced a precipitous and alarming decline across its range, with estimates suggesting a devastating reduction of over 80% in the last 100 years alone. This drastic and rapid decline has led to its classification as vulnerable on the IUCN Red List of Threatened Species, a global indicator of conservation status, and it is officially listed as threatened or endangered in various states across its historical range, including Florida, Georgia, Alabama, Mississippi, Louisiana, and South Carolina. Specifically, the Western Distinct Population Segment, DPS, encompassing tortoises found west of the Mobile and Tombigbee rivers in Alabama, extending into Mississippi and Louisiana, is federally listed as threatened by the U.S. Fish and Wildlife Service, USFWS, while the Eastern DPS covering Florida, Georgia, South Carolina, and most of Alabama is currently considered robust by the USFWS. It still faces significant threats and constant criticism from conservation groups who advocate for its full federal protection. The primary and most pervasive threat to the gopher tortoise's continued existence is undoubtedly extensive habitat loss and severe degradation. This is predominantly driven by relentless human activities such as rampant, uncontrolled urbanization, large-scale agricultural conversion of natural lands into monoculture crops, and unsustainable forestry practices that prioritize short-term timber production over long-term ecological health and biodiversity. The once vast longleaf pine ecosystem, which represents their preferred and essential habitat, has been drastically reduced to fragmented pockets, directly impacting both the availability of suitable sandy soils for burrowing and the crucial herbaceous forage plants that constitute their diet. Other significant threats include habitat fragmentation itself, which isolates remaining tortoise populations, hindering gene flow, reducing genetic diversity, and dramatically increasing risks from road mortality as tortoises attempt to cross dangerous thoroughfares to find mates, new foraging grounds, or escape disturbances, leading to significant vehicle strikes. Direct human interference, such as illegal collection for the burgeoning pet trade and being sought for food in some areas, historically referred to as Hoover chicken during the Great Depression due to its availability, also contributes substantially to their decline. Furthermore, historical and ongoing fire suppression, while understandable near human settlements to protect property, severely disrupts the natural fire regime essential for maintaining the open, herbaceous understory of longleaf forests, making habitats progressively less suitable for tortoises by allowing dense, unsuitable hardwood vegetation to grow and shade out their vital food sources, changing the entire ecological structure. Diseases, such as the debilitating upper respiratory tract disease, URTD, also pose a significant challenge, particularly in crowded or stressed tortoise populations, further compounding their vulnerabilities. recognizing the gopher tortoise as a definitive keystone species, absolutely critical to the survival of the over 360 other species that depend on its burrows for shelter, moisture, and survival, fundamentally underscores the profound urgency and necessity of robust, multifaceted conservation efforts. Protecting the gopher tortoise inherently means protecting an entire subterranean and indeed above ground ecosystem, a vast network of interspecies relationships. Conservation strategies are therefore multifaceted and complex, embracing a holistic approach that focuses intensely on large scale habitat restoration, particularly of the dwindling longleaf pine forests. This is achieved through essential land management practices like prescribed burning, which meticulously mimics natural fire cycles, actively promotes the regeneration of suitable herbaceous ground cover, and maintains open canopy conditions crucial for tortoise habitat. Land managers also employ careful planning, including sustainable timber harvest methods that preserve old growth trees and selective use of herbicides to control invasive species, all aimed at maintaining open canopies and diverse ground cover plants, while simultaneously minimizing soil disturbance to protect existing burrows and their resident populations. Establishing and expanding protected areas, along with strategic land acquisition initiatives, are absolutely crucial for preserving large contiguous tracts of high quality tortoise habitat, providing safe havens from relentless development. Additionally, translocation programs, where tortoises are carefully moved from areas slated for development or immediate habitat destruction to secure protected receptor sites with suitable habitat, are increasingly utilized. Some innovative programs even involve giving young tortoises a head start in specialized nurseries or protected enclosures to significantly increase their survival rates before release into the wild, as their early years are fraught with exceptionally high mortality rates. Public awareness and education are also vital components of long term conservation success, fostering a broader appreciation and understanding for this unique reptile. Gopher Tortoise Day, celebrated annually on April 10th across its range, serves as a dedicated platform to raise public appreciation for this iconic species and educate communities about its immense ecological benefits and its role as an ecosystem engineer. Individuals can contribute meaningfully by actively avoiding disturbance to burrows, respecting the mandatory 25-foot protected zone around active burrows where development is prohibited without a special permit, reporting any illegal activities such as collection, harm, or harassment of tortoises, and even planting native tortoise-friendly vegetation on their properties to provide supplementary food sources and potential habitat connections, creating green corridors. The enduring legacy of the gopher tortoise lies not just in its impressive longevity, its ancient lineage, or its calm, deliberate demeanor, but profoundly in its role as a quiet, unassuming architect of life, a humble burrower whose patient, tireless work provides indispensable refuge and sustains the vibrant biodiversity for countless other species. Its continued survival is intrinsically linked to the health and vitality of its entire ecosystem, and by diligently working to protect the gopher tortoise, humanity collectively safeguards a rich tapestry of interconnected life, contributing to improved soil health, better water quality through reduced runoff, and preserving invaluable natural spaces for future generations to explore, learn from, and cherish. The future of these unique ecosystems and the myriad lives they cradle and sustain rests squarely on continued dedication to understanding, respecting, and protecting this truly remarkable keystone species, ensuring its enduring presence for centuries to come.